It better work. 5, 4, 5, 4, 5, 4, 5. Yes, oh my god, it works. Am I even? Is there audio? Please tell me if there's audio. Is there audio? Please. Let there be audio. 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 Please let there be audio. Please let me in. Am I live? Let's play KSP in the meantime while we wait. Yes, there's audio. I think. Is there audio? And I'm still okay. So, over here. No, it's over here. Over here, at the other side of the screen, you can see the stream of the Sentinel-3B launch. And are they starting again? We'll be back in 20 minutes. Yes, that's good. Are they only going to play this stupid theme? You'll be back soon. It's yellow. Oh god. No, it's still
That
okay.
was 1 minute and 1 hour and 8 minutes ago. We are 1 hour and 8 minutes into the flight of Sentinel-3B. It's a European Earth observation satellite, which is going to help us better understand our planet. It lifted off from the pad at the Russian Cosmodrome in Plesetsk on board a rokot launcher, and we've been coasting without the engine ever since for the last 54 minutes or so. We are coming to you live from the European Space Operations Centre in Darmstadt in Germany, and as I mentioned earlier, ESA is doing a live event at the Berlin Air Show for the launch, and best wishes to everybody there. Earlier, we caught up with the Director of Earth Observation Programs, Josef Aschbacher, and here's his overview of the mission.
With the launch of Sentinel-3B, Europe is putting together a fully operational system based on the first batch of Sentinels in orbit right now. With Sentinel-3B, we will have 7 Sentinels in orbit, 2 each of Sentinel-1, of Sentinel-2, Sentinel-3, plus Sentinel-5B. And these satellites are measuring a variety of parameters and providing a variety of information for many people. For example, for farmers, to estimate the amount of crops which is being produced and monitor the state of the agricultural fields. Doctors to see what is the air pollution in a certain area and whether the city where people live in is particularly endangered. Civil protection agents to better respond in case of crisis and disasters like flooding, earthquakes. For ship captains to better navigate their ships and make sure that they are not hitting an iceberg. But also politicians need to know, and they get better information about food security in Africa and to realize what needs to be done to really contain a global crisis which might develop. So these Sentinels really provide fantastic information to a number of people and really are of great economic and societal value for Europe. External studies have estimated that €1 invested in Copernicus brings back about €10 to the economy if all the data are used in a free and open way. And this is one of the success criteria of Copernicus, that these data are for free, available for everyone globally. And it's a very good example how Europe works together successfully. The European Union,
This is one of
the
those
European
moments
Commission
I hate
providing
OBS.
leadership and political guidance and co-funding of the system. The European Space Agency being in charge of implementing, developing and operating the space component. EUMETSAT also operating parts of the space component, some of the Sentinels, but also of course the member states of ESA and the European Union, and industry who is building the space infrastructure. But also user organizations like the European Environment Agency, Frontex, the European Centre for Medium Range Weather Forecast, the Satellite Center in Torrejon. They are all using this data in a routine way for their daily purposes. In short, it's a good example how Europe works at its best.
Joseph Aschbacher. I'm Katie Haswell and I'm with Philippe Goudy, the head of Earth Observation Projects at ESA, and Nick Mardle, who's the head of the Earth Explorer Management Office. And we'll be taking you through the rest of the programme. Nick, what's been happening in the launch so far?
So, as you mentioned earlier, we launched an hour and 12 minutes ago, and the initial part of the flight was to burn the first and second stage to perform the main propulsive part of the launch.
And then seriously
breeze
crashed
the third
on
stage,
start.
The upper stage took over
Wow.
and fired for roughly 500 seconds to achieve an orbital velocity so that it could stay in orbit, but it's a relatively highly elliptical orbit, so it's very egg-shaped. And then the breeze shut down and we started the cruise phase, which is where we are at the moment.
And Breeze will be getting ready to switch its engine back on in a few minutes' time for the second burn. Philippe, while we're waiting for that, let's talk about our satellites. Why are the Sentinel-3 satellites important?
Well, first of all, I think that all Sentinels are important because all of the Sentinel are bringing their set of data, and it's really putting together those various information that is helping our understanding of the Earth's environment. Now, amongst its variety of mission, one can say that Sentinel-3 is probably mostly focused on ocean, and it has an instrument for ocean temperature, for what we call ocean topography, which is the height and the low of the surface of the ocean, but also what we call ocean color, which is a measure of algae and all the biologies that take place inside the ocean. And we know that more and more oceans are crucial for our environment. Many people live close to the coast. The oceans are also driving the overall climate, or are part of the overall climate loop. And this is really what makes altogether Sentinel-3 very important.
And as we mentioned earlier, the Sentinels come in twos, and Sentinel-3A, the twin of Sentinel-3B, launched 2 years ago, in 2016. What is Sentinel-3B going to add to it?
Well, basically all the Sentinel series were designed to work in tandem, and so this is the
what
second
they're
half of
doing
the tandem, and what it will bring, what Sentinel-3B will bring is
basically
actually more data, and this is with Sentinel-3 and 3B that will be able to monitor some of the instruments, the whole Earth in one day, which was never really done with that accuracy before.
Coming closer now to the switch on of the Breeze.
They're going to switch on the
upstage
engine for the second time, so they're in a large
time.
elliptical or elliptical, it's slightly elliptical,
See there
and
the
now
CGI
they're
images
gonna
of what we're looking at. That's the
switch
Breeze
on the engine
upstage,
for a
now scheduled to
short
switch its
time,
engine
and
on.
then
You can see it there, and the satellite attached to it. So we're really entering the next phase now. Nick, why has Breeze switched its engine on again?
So now after the cruise phase, we've reached the highest point of the orbit, but it's no good where it is at the moment. So what we need to do is circularize the orbit so that it's in the same altitude for the whole time that it's flying around the Earth. And it's most efficiently done when we're at the highest point, and that's where we've just arrived at the moment. So the breeze will burn for 32 seconds roughly, and then it'll switch down, and then we'll be in a circular orbit.
There you go. They switched off the engine.
Sentinel-3B was built by Thales Alenia Space.
Now they're going to separate it.
Experts at building Earth observation
And
satellites.
this is
And
actually,
ESA's remit
there is
was to
no
equip the
data.
two Sentinel-3 satellites with 4 different types of instruments.
They will come
This
over.
is sophisticated technology. We're going to take a closer look
what
now
is
at the
the
instrumentation
Darmstadt?
on Sentinel-3B.
Sentinel-3 satellites carry
then
a suite of optical and
we will
microwave instruments
be
working in
seeing
synergy.
if it
Sea, land, and
works or
surface
not,
temperature
because it will be
radiometer
deployed in a few
measures
seconds.
global sea and land surface temperatures across a wide area, with an accuracy of better than 0.3 degrees Celsius. The Ocean and Land Colour Instrument measures 21 distinct spectral bands. It monitors a large area as it passes overhead. The synthetic aperture radar altimeter provides total coverage of the Earth's surfaces.
So yeah,
Along with the other instruments in the topography payload, the microwave radiometer and precise orbit determination, it accurately measures land and sea height.
Philip, this is cutting-edge technology, isn't it?
Yes, really, all this suite of instruments
hey, you're back.
are
Yes.
really indeed state of the art, I would say.
So what they
And,
did
one has to
is they
realize,
raised the orbit.
what
It's
it
circular
takes. We were
now,
mentioning in the
and
movie,
they will release the satellite, and then
temperature
we will
measure-
see if
measuring
it
instrument.
works, because they will be
I want
getting.
to stress
There
out,
is no actual
looking
data
from
now,
800 kilometers,
and
you
we don't know
look
if it's
monitoring
separate.
the
It's going to
sea
separate
temperature
successfully.
with
We
an
will
accuracy
know
better
if
than
it works when
0.3
it comes over
degrees.
Darmstadt.
Anyone who has been
That's
putting
when they
two
will check out
thermometers in our
everything
room
and
finding that the measurement
see if
don't
it
really
works or
coincide,
not.
can see what it takes to really bring such accuracy from above. Similarly, the radar altimeter, where from 800 kilometers will measure the sea height to precision that in the order of 1 centimeter. And again, you can one can think about how much care you need to put into building and also calibrating and making sure that those instruments remain stable over time.
We're getting close now to the scheduled separation. We're about less than a minute away. Nick, we're going through a set of orientation manoeuvres up here, aren't we? The upper stage is... Well, we can't really see it twisting and turning too much, but it is actually doing that.
Yes, that's right. The final activities that the rokot and the breeze and the satellite go through is a rotation maneuver, so that effectively it's flying backwards, and at that point you get the separation, so the two will start to drift apart.
So it will
and
separate
then
it
the
in
breeze
just a
is
few
in the right
seconds.
orientation to do a deorbit maneuver, so that it can then do the deorbit to move away from the operational orbit of Sentinel-3, so it doesn't cross again, but then later so that it can deorbit correctly and land safely in the sea.
Sometimes people refer to the separation maneuvers as the space ballet. And we're getting closer now to the scheduled separation time, which of course we can't actually confirm at this moment, can we, Nick, because of the telemetry?
That's right. Although the spacecraft and the breeze are separating, we can't see that because our space stations, our ground stations, don't actually have line of sight. It's as if the spacecraft is below the horizon for our ground stations. So until it comes above the horizon, we can't be sure what the situation is.
So what's happening now?
So yeah,
So now the teams are waiting. The ground station is ready. The antenna is pointed at the horizon, waiting for the moment that the signal comes in, and then we'll know that the spacecraft is arrived at the right point at the right time, and from there we can work out what the situation is
So yeah,
with the satellite,
they
if it's
will
doing what it should do,
basically
or there's something that we have to intervene with.
see if it works or not. should be separating right now. And
just remind everybody, Philippe, what we're looking at, the Breeze upper stage with the satellite attached.
Indeed, and we shall have, let's say, the animation showing the separation for the spacecraft, which is really the time when it starts flying on its own, and it starts its own life, because this is the time where it will initiate its own automatic sequence in itself. And so it's really the crucial moment that the confirmation of which will be waiting as soon as it gets over the horizon over the Kiruna station.
so what he's talking about is the
Now, while we're waiting for that confirmation, we've been seeing the teams in the mission control room. But that's the tip of the
Germany,
iceberg.
I believe, yeah.
There are lots of teams working on the Sentinel project. Another one of them is
And
the
they
project support
have pointed
team.
their
And I did get a chance
antennas
to talk
on
to them earlier.
the horizon, so when it comes up on the
This is the
horizon,
project
they will
support
catch
team.
it. They will
So ESOC is
see.
controlling
You
the
will have
immediate
those radio
operations
lines,
of,
and you will
of the
see
satellite. But of course, many analyses have to be
First,
done in the
it's
background.
going to
and
be
checks
very
have to be
slight,
performed.
but afterward,
So this team
after a
is
few
composed
seconds,
of
it
the
will grow
team of
into a
European
large
Space
spike,
Agency,
and then
ESA,
they will
and
know
our
it's
industrial
okay.
prime contractor,
And if we
Thales
have
Alenia
no
Space
spike,
from
it's
Cannes.
not okay,
And of
and
course, there are
we
many
might need to do
people
some
also in the background
fixing.
supporting if there would be questions and problems to be solved. So you can see here, for example, all the disciplines are located, and the most critical ones is the electrical power. It's like any electrical machinery needs power. So this is the most critical. We have to bring the satellite into a situation where the solar array is deployed and is collecting power to charge the battery. And this is done here. And then, of course, the AOCS is a very important function, which is also represented here. Thermal control, not to forget, let me say, like any, let me say, machinery, it is cold, it can be cold and it needs to be warmed up, or it is warmed and it needs to be cooled down. So all these analyses and checks are done, background checks are done in the support room. We work since 2007 from the design of the spacecraft on this, let me say, for this important event.
I'm going to check
this
if this
time,
is
and we are very, let me say, enthusiastic to bring it in orbit, like for the S3A.
So it's all about teamwork, and also teamwork between ESA and EUMETSAT, because the European Space Agency operates the Sentinel satellites in conjunction with the European Organization for the Exploitation of Meteorological Satellites. EUMETSAT helps to exploit the information that the satellites collect, and it is vital for helping to understand climate change and for weather forecasting.
In EUMETSAT's dedicated Copernicus control room at its headquarters in Darmstadt, engineers work 24/7, commanding and monitoring the Sentinel-3B
So yeah,
satellite.
this is the last
Now they're
dedicated
getting ready
Sentinel
for
satellite that was
Sentinel-3B.
launched.
And twice as much
I
data.
love German
In the
accent.
first 6 months of operations,
Yeah,
we put in the same amount of data
it's
into our
funny.
archive as in all the
And
previous
Sentinel
programs
4
from our
will
lifetime.
be an instrument
Everything's
or
bigger,
an
better,
instrument
faster.
package
The
aboard
amount of
a
data, the accuracy of the data gives us more chance to actually identify parameters more accurately. which of
older
course leads to
satellite,
improved
and the same is
climate
for
management,
Sentinel-5 and
weather
Sentinel-6, I
forecasting,
believe.
because we have more accurate data.
After the initial commissioning phase, the twin Sentinel-3 satellites will fly in series around the Earth, approximately 40 minutes apart, enabling them to cover the entire planet in 2 to 3 days. The Copernicus team here processes and analyses ocean data collected by Sentinel-3's suite of instruments and turns it into useful scientific products.
Sentinel-3 is a mission that's primarily focusing on monitoring the ocean's different parameters, for example sea surface temperature, sea surface height, wave height, and also sediment and ocean colour parameters, where you have things like plankton or sand, transported by the ocean.
Changes in global ocean temperatures, visualised here with 2016 data, can have long-term implications for future climate. But near real-time data from Sentinel-3 It's also fed into shorter-term weather forecasts.
So Sentinel-6
The temperatures
is
of the ocean
a
is what provides the
Jason
energy
3
to drive
follow-up.
the weather
So
system. So if you've got
Jason
areas
will
of warm
was
in
launched by
the ocean,
SpaceX, and
this
this
can
will
provide
be
enough energy, for
also launched
example,
by
to feed the
SpaceX, but the
hurricane.
satellite is a
So
follow-up of
it is the energy store of the
the
Earth.
Over more
SpaceX.
than 30 years and with multiple missions,
And I don't
EUMETSAT has
know for
transformed
the
weather
rest,
and
but
climate forecasting in Europe.
for now, for a
Sentinel-3B
coming
will
period,
double the capability
this
of
was
this
the
program of ocean monitoring satellites,
Sentinel satellite
improving
that was
global
launched.
predictions for the state of the seas, future climate and weather forecasts.
And oh no, it's
We're
not.
going to go back now to the
Sentinel-1
room here at
will
European
consist
Space
of 4
Operations Centre
satellites.
and speak with Rolf Denzing,
Sentinel-2
who's the Director of Operations, and
is
Paolo Ferri, who's the Head
consisting
of Mission
of
Operations Department. Gentlemen, thank you very much indeed for coming to chat with us. Rolf, let's start with you. How important are missions like this for ESOC?
Well, let's consider that European taxpayers have invested a lot of money over the last
and
50 years.
this Sentinel
to build up this,
will
unique
be
world-class
also
operations center. And so it's good news,
Sentinel-D
that
will
they now,
be the last one that
operate
launches. So
this, institutional
Sentinel-1
mission
will
out of
have
European
Sentinel-1A,
institutional
B,
control
C,
centers.
and D,
So,
and
I must say it has been
Sentinel-2
exciting, it
only
has been
have
fun,
A and
it's
B.
good for our
Sentinel-3
people.
will have
It's
A, B,
very
and
interesting
C,
mission.
and
So,
I think they
we
will
like
launch
challenges, we like
Sentinel-4
to
as
fly
a package on
satellites,
the other
we like
satellite,
the
but
excitement
they
of,
will have 2 of these
launch
satellites.
and, early
Sentinel-5,
operation
I think, the
phases.
same, but it
this
will
is,
be another
the excitement
package.
that we are feeling
And
here
then
today.
Sentinel-6 will
And what are
be
you most proud
a
of,
cooperation
Rolf,
with
over these
NASA,
last 4
and
years?
NASA
I guess
gave
it's
the contract to
teamwork and
SpaceX,
the
so
teams
that's how
you've
it
been,
works. So for the
you've helped
coming
to bring us
period,
to
this
this.
was the last
Well, so far,
launch of the
most
Sentinel, of a
importantly,
Sentinel satellite.
everything has gone flawless. So we have managed to bring all of these satellites in a really operational state. Everything went as it should be, despite of challenges we had in a very early launch of the Sentinel series. We had a collision avoidance during a collision warning during a launch phase, and I cannot think of any other place in Europe that would have mastered it the way our colleagues did it over here in ESOC, and this was before my time, so I cannot personally take credit for that.
Thank you very much indeed, Rolf. Paolo, over to you. You've launched 7 Sentinels in 4 years. What have you learned during that time?
7.
A great deal. The team, of course, has done these operations many times. The satellites are different from each other. Okay, the Sentinel-3B is identical to 3A, but they are a series, and we reduced dramatically the effort required for training, for example, because in the beginning everything was new. In the end, we had a lot of things that our team had learned. The systems that were developed are very common across the satellites, and basically for every mission they get a little bit better. So there was a huge learning process.
And it's been a really fast turnaround between missions, hasn't it? Which I guess is hard work, but also a great opportunity for the teams.
Yes, absolutely. You see people very rapidly growing from one position to the next. It's extremely efficient to give career opportunities within such a integrated team. So people that maybe are playing a certain role in the beginning of the 4 years, they grow, and in the next launches they play a higher level role. We have the opportunity also to train and prepare also young engineers and young colleagues. So it's been really an incredible opportunity for the team.
Well, best wishes to all of you now as we get closer to the acquisition of Signal. And thank you very much indeed, gentlemen. Nick, what's happening right now? What are we waiting for?
So we're waiting for 2 things. The first is that the spacecraft fly over the Russian monitoring ground systems, so that then they can have confirmation of the rokot part of it. But then we're also waiting for Sentinel-3 to arrive at Kiruna. Now, Kiruna is our first ground station, and from there we'll see that all of the initial activities have happened correctly after the separation. So all of the autonomous onboard commanding has been performed, and that the transmitter has switched on, and the the attitude control systems are starting to work properly, and hopefully we'll even start to see the deployment of the solar array. So we're all waiting for this. This should all have been happening whilst we're waiting after the separation, and we're just now waiting for the spacecraft to reach a point where
there you can see the line, and if everything is correct, you will see a very high a spike,
when we have a
and then
mission,
we'll
there
know
will be
the satellite is okay.
early operation phase, the LEOP phase, where we will stabilize the spacecraft, make sure turn it on gradually, and make sure that everything works well on the platform part of it. Then a little bit later on, beginning of May, we will, in a staggered fashion, turn on each of the instrument, finishing by SLSTR, which has to be cooled down first. And then each of those instruments will undergo a series of tests and will be compared with their predecessor, with ground measurements, to really do what we call calibration and make sure that what they measure corresponds to the actual physical parameter. And this will take about 5 months or so. But we are, of course, this is all pending the successful separation that we're all waiting for its confirmation, I would say, any time now. And we shall be with
so watch the screen on your
Kiruna station.
right,
now waiting,
the screen above the map of the Earth. That's the radio signal, and you will see the spike.
Wait for that acquisition in a second, but just before we do, can you describe to everybody what they need to look out for on the top right-hand screen? What will they see?
So here they'll see the signal as it's being received at Kiruna. So you should see a big peak in the center of the screen, which means that the right frequency is being received by the antenna. And once we have that, then we can know that we've got the transmitter on.
So we'll sit back now, turn our mics off, and wait for the peak.
Oh my god, I hope it's okay. This... nerves. This is a... yeah! Is that a spike? Yes! It's a spike! Woo! We made it. It's there.
We have signal acquisition. Very good.
It's alive! It's alive! Okay. I guess this is a good moment to go over to
some audio the loop. Yes, with this I was about to call you. So from first TM check, I can see that the spacecraft mode is in it. IOCS is in rate dumping mode as expected, and separation has been detected, and the solar array wind deployment is currently ongoing. Okay, thank you, Sam.
Okay, we can announce that we have the spacecraft, and was exactly at the time in Kiruna.
So
the sequence of dumping is ongoing.
To be quick,
spacecraft of course is separated,
and not to make this a too long
the
stream.
solar array deployment sequence started, and
I'm gonna close
if
this.
we are lucky.
And yes, I have KSP running. So yeah, quick, I'm gonna make this in Kerbal Space Program, and I think this is right. Let me check. Okay, so first of all, first things first, let's make the satellite. Sorry, you're taking the channel seriously or fun? I'm taking it seriously as long as it is still fun. And yeah, so I'm not really sure, but hosting, yeah, I'm for hosting I'm really serious. I want to be really serious for hosting because that's cool. And I love it. So yeah, why not? But yeah, I don't think I'm gonna take it too seriously. But yeah, I love to have it more serious for in future. So yeah, let's create this. I should make a video of this. Let's put some fuel and RCS inside. RCS. Let's put some fuel inside. Fuel. A little less fuel. Less fuel. And let's put some batteries up here. That's one, that's two. Probably way too overkill, but nah, I don't care. And have the engine. And I have this problem when I attach the engine like this, it doesn't draw any fuel from the tank. So what I'm gonna do is I'm gonna clip it in the upper part, then have a fuel line from the spark engine. No. I need to do it like this. And then this is not cheating. This is just, it's a bug in KSP, so oh no, I can't do it. No. That's sad. Oh, wait, I can. Ha ha ha. F you, KSP. Sometimes. So what's your favorite rocket? Let me see if I can do this. Yes. And we need the solar panel. So I have a few solar panels. This looks like the one from the Sentinel. Right in the middle. Oh no, it only has 3 panels. They're just too long. Oh no, what did I do? No. Ugh. Okay. This looks way better. Then there is a dish on this side. And this is more on. It looks really weird, but and then just for actual, let's put a multi-spectral scanner on. Put a few thrusters on. And now let's put this one on. Okay. This is one of those times when I don't like BFR. That's a good choice. I like it too. But I would more. I think I would go for. I don't know really. And why I don't know is because I like the Delta 2. It has a special place. But I also like the Indian rockets because they have so much staging going on, which I think is fun. No, the antenna is too big. Let me change it for another one. Yeah. No, I don't want symmetry. Yeah, let's go. Let's launch. Okay. I know it's not really correct, but I think it's close enough. Oh. Let's put the engines on, or actually the... So, yeah. This is not the correct stage. This is a Zenit rocket. I've chosen the wrong one. No! Ugh. This is probably correct though. Let me see. What should be the correct one then? Is this the one? No, it's not. Is it this one? I am confused. Craft. If they are wondering what mod I'm using the... No, that's the Energia. That's... Okay, let me check. Unsymmetrical. Yeah. Unsymmetrical is the word for it. Now I'm gonna look up whatever. Ha! Lol, I was using the wrong one. This one is smaller. Yes. Oh my god, yeah. I was using the wrong one. Oh my god, no. Okay, the fairing is not correct, but I'm not bothered by it anyway. So, yeah, finally. I'm raising money to buy KSP. Lol. I bought it a long time ago, so you should buy it though. It's great. Let's make it a bit smaller. So yeah, it looks a bit ugly, but okay, first check your staging. Flip up, deploy that there. Okay, no, the fairing has to go while the second stage is burning. Deployment satellite burn. Yes, let's launch. It's the best game ever. Yeah, it is. When you buy it and you love stock textures, you should get this mod. It's Contares. Let's go. Let's launch this. Oh god, the acceleration is... Seriously? I could build... Okay. Okay. I'm not gonna bother. Okay. Ooh, it's wiggling. Outer strut. Okay. Ooh, no. Okay. I destroyed it. Oh. But you can see it leaps off the pad. Let's go again. 3, 2, 1, go. Oh no, that's the wrong way. Nah, I don't care. It's a polar orbit anyway. Let's go. Let's go. This was a bit too much. Yeah, this was too much, I think. Nah, maybe not. Oh. Let's go. Go, go, go. Oh, my face cam is gone. Wait, let me Let me fix that. Oh god. Oh. Oh no. Oh, it's getting a bit hot in here. Man's not hot. Okay, deploy. Go for it. Too early gravity turn. No, it's a little too late, I think. Is my frame rate like crappy on the stream? Because it's a smooth frame rate from my point of view, but guess I could be wrong. Okay, this is the part where I talked about my high point is way too high and my low point is way too low, so let's just power. There's a square on my face, is it there? Oh, ugh. Not anymore. But now my game quit, so. Anyway, just go for it. I will fix it anyway. Let's go to 300, then cut it off. 300. Okay. Warp here. Time warp complete. Okay, let's go. Let's go. Let's go. 3, 2, 1, fire. 50, 80, 100, 130, 50. Whoa, 200. And we've reached 300. Cut it off. I had seriously 1 meter of delta V left. I have 1 meter of delta V left. Wow. This is seriously, this is some. I think I should be as a rocket scientist. This is some seriously good trajectory engineering. Wow. Oh. But it's not. Okay. Let me fix the inclination. Just deploy the solar panels. Keep. Let's start it. Where did Kerbin go? Oh, there. Okay, so. Oh, God, no. I didn't want that. Ugh. Let me just set up a maneuver. And. Let's do this. Lucky you, yeah. And I shot it in in the correct orbit, I'm gonna lower it to 300. So 33 seconds till my burn. 6, 5, 4, 3, 2, 1, fire. So, realism overall is really difficult. It's really hard to launch rockets. You basically you need to get the trajectory correct, otherwise you'll just end up burning. Especially with, in my opinion, the Delta 4 is really difficult, and the Atmos 5 too, because the lower stage has a lot of power and a lot of push, but the upper stage doesn't have that much of a push actually. So basically what ends up happening is my initial trajectory is way too shallow, then I separate and I discover I can't keep my my vertical speed up, so I just end up falling back into the atmosphere. So yeah. Oh, controls are locked. I need to have a better communication system thingy. And I have scan set. This is really cool. I have scan set, so once I look, it's actually, why isn't it? Map type, slope, biome. Yeah, it's scanning my planet. It's scanning Kerbin. So you have. Are there a way to? Yeah, there are. I'm actually working on coding for an Ariane 5, and it's hard. It's really hard. That's. Okay, it's not working between those altitudes, so let me go ahead and do this. Wait, my screen is adjusting for the fact that it's getting dark, so yeah. Not anymore, ha. So yeah, let's plan another maneuver. And periapsis, periapsis, and move it into a perfect orbit. And I'm gonna do this maneuver with RCS. Otherwise I end up overdoing it. Ugh. Advertisements. No. Oh. This is not an advertisement. Oops. So yeah. This is how you launch the Sentinel-3 satellite into orbit. But this, yeah, you will learn a lot. I call this a perfect circular orbit. Look at my orbits. Oh, it's my face in front of that. Let me just move my face. Look, I have a perfect orbit. Or almost perfect. So yeah, this is how you launch a Sentinel satellite into orbit. Ta-da! It's there. It's orbiting. Kerbin. Hey. So yeah, is there another rocket you will would like me to launch, or another mission? I did this quickly. Let's save this. I could make this Salia and launch it, or this was the, I mean, let's build the ISS. Let's do it. Let's build the ISS. That would be fun, though. But I would need a shuttle. I don't have one at the moment. I don't have the mods for it. Nah, can't do. No such thing yet. Oh. Is a Delta rocket in here? Let's make an Ariane 6 launching a whole constellation of satellites. Let's do it. Let's get the Vinci one. Let's get the computer in. Computer. The computer says no. Computer says yes. Computer says yes. Okay, no, not yet. So, can I put this in? No, that's too big. Yeah, let's put this in. Fun but hard. What's fun but hard? No, let me do this differently. So I'm gonna have tiny communicating satellites in here. Solar panels? Of course. I can do this even. Wait. No. Let's do it like this. There need to be relay satellites. So let's look for a. This is a relay dish. No, not 4, only 1. Let's. This, I think, is this a good enough satellite? Ugh. No, wait. Let me change it for the other one. This one. It just fits, I think. Let me do it differently again. Let me get rid of those. Can you launch one after that? Yeah, but I need correct mods and I don't have it. I could do a building the ISS stream sometimes, but it's hard to launch one. I need to figure out what's okay for streaming. Maybe I could do a sort of combined stream sometimes. I don't know. And whoa, it's already 10 o'clock. Wow. I've been doing this for a long time now. Do this. Move this inward. Move it in a little more. Okay, this is how. Oh no, this is not what I wanted. It's not what I wanted. Yes, I need to move this inward. Don't let these touch. Yeah, that's good enough. So now I need. Ugh, no. I don't like clipping parts, so I need to rotate these slightly. There we go. Ariane 5 launching a whole constellation of 3, 6. Let's do 10 rows of 440 satellites. Let's do it. Just launch. No, I don't have the correct mods to launch a shuttle. I could try, but it will burn up on re-entry. Well, you only want to launch, so. But I don't think it really works. I could try. Let me just finish the Ariane 5, Ariane 6, I mean. Save. I don't want a shroud. No, go away. get the decouplers on. I'm gonna build a shuttle in a second. I thought of a way how to do it. I could try. Let me just do this. Ooh. No. Oh, they're here. Oh, what is this? No, I don't need this. This is crap. Crap. Oh, crap. This is not crap. This is what I need. This is what I do. I sit on you, sit on you, sit on you. This is what I do. I sit on you, right on your lap. This is what. Okay, no. Okay, I did it. Yes, I built a whole satellite system. Autostrut, enable autostrut. Oh god, I need to enable autostrut for every one of these. Ugh, let me do this differently. I think I'm gonna lag here, guys. That's 1. That's 2. Five. That's. Oh god, no. 10. Okay, yeah. How bad is the lag? Let me see. Yeah. Okay-ish. Okay. Let me get my staging correctly. First the engine, then these, then these. Yeah, let's go. Yeah. Let's go. Let's go to space. On an Ariane 6 launching 40 satellites. This is so stupid. I love this. This is why I play KSP. Oh god, the lag is real. Nah, boring. I'm building a shuttle for you. Save this. New. So yeah, guys, thanks for watching again, and Astra to the stars. Let's go.